Conic sections in the real world. Conics can be found anywhere from your kitchen to your living room to your own backyard. So, here we can see, on this shop clamp, there's a parabola along the edge. Along the seat of this swing set, we see another parabola. However, this parabola is not man-made. It is created by the middle section being pulled down by gravity. This level features a parabola that appears to have the highest slope of all the parabolas that I found. The second conic, the circle, is probably the most common of all the conics that we see in our lives every day. Here we see 4 circles on the back of this propane tank, and here we can see in this clock there's a circle. Moving on, this solar yard light is another example of a circle. And finally we come to this ball-peen hammer. This hammer is an example of 3 of the 4 conic sections all in one object. Along the top and bottom edge, we can see a hyperbola. Note the distance between the 2 curves, as this is known to be the transverse axis. Perpendicular to the transverse axis, there is the conjugate axis. Using these 2 lines, you can form a rectangle from which you can draw the asymptotes. The next conic in the hammer is the aforementioned circle, located at the head of the hammer. The third and final conic on the hammer is the ellipse. I've decided to calculate the equation of this ellipse, so first I start by measuring out the lengths of the major and minor axes. Starting out simply by putting the center at 0, 0, we can use the major and minor axes to draw the ellipse onto a coordinate plane. In order to find A and B, we have to divide both the major axis and the minor axis by 2. Using A and B, we can easily find the vertices by adding A to the y-coordinate of the center and subtracting A from the y-coordinate of the center, giving us our vertice coordinates of 0 plus or minus 1.805. Next, we get C by using the formula c squared equals a squared minus b squared. Simply plugging in the numbers, and you get c squared equals 1.008, square rooting that, and you get 1.004 or negative 1.004. Therefore, the foci are 0 plus or minus 1.004. While the foci aren't necessarily required for the equation, it's good to know how to find the foci. And so with A and B, you just plug those into the standard equation, and you're done. Next, I decided to use my equation of the circle to find the equation of the top of the solar lamp. So I measured the diameter of the solar lamp, divided by 2 to get the radius.